Alright, let's open the right page. Europa. If you examined this moon through a telescope with enough resolving power, you'd see a world that looks like a cracked egg. Smooth and brilliantly white, crisscrossed by thousands of kilometers of reddish-brown lines running in every direction across a surface that has almost no impact craters. The craters that 4 billion years of bombardment should have left are largely erased, continuously overwritten by a process that has been resurfacing the crust across geological time. Europa is the fourth largest moon of Jupiter, orbiting at a distance of 671,000 kilometers with an orbital period of 55 Earth days, and it has the youngest large body surface in the solar system, estimated at between 20 and 180 million years old, which in geological terms is nearly fresh. Something maintains this youth. That something is a global saltwater ocean, sealed between 10 and 30 kilometers beneath the ice shell, kept liquid by tidal heating generated as Jupiter's enormous gravitational field stretches and compresses the entire moon with every orbit, converting mechanical strain into heat in the rocky interior below the ocean. In 2016, the Hubble Space Telescope captured images showing what appeared to be water vapor plumes erupting from the southern polar region, extending hundreds of kilometers above the surface. If those plumes are confirmed as venting ocean material, which ESA's JUICE mission and NASA's Europa Clipper, launched in October 2024, are designed to determine, then a spacecraft could fly directly through the ejected water and chemically sample the ocean without landing and drilling. The Europa Clipper is scheduled to begin its close flyby campaign in 2030, conducting approximately 50 passes at altitudes as low as 25 kilometers. If life exists anywhere else in the solar system right now, Europa's ocean is one of the most credible candidates for where it might be found. The question of whether we're alone has a realistic chance of being answered there within this century. Phobos. Mars has two moons. Deimos is the smaller one, distant and quiet, unremarkable in almost every way. Phobos is the other one, and it is one of the strangest objects orbiting any inner planet in the solar system. It measures roughly 27 by 22 by 18 kilometers and elongated lumpy, heavily cratered, object shaped like a battered potato, and its surface is buried under a layer of powdery regolith estimated to reach 100 meters in depth in places. The accumulated debris of billions of years of micrometeorite impacts that Phobos' weak gravity barely retains. The Stickney crater dominates the body in a way that should not be physically possible. It is approximately 9 kilometers across on a moon, only 22 kilometers wide at its broadest point. The impactor that produced Stickney delivered enough energy that, for any structurally solid body of Phobos' size, the resulting shockwaves should have transmitted through the rock and shattered the moon entirely. The fact that Phobos survives strongly implies its interior is not solid but porous, a loosely consolidated rubble pile held together by its own weak gravity, able to absorb shockwave energy through compression of void spaces rather than transmitting it as a destructive wave. The ESA Mars Express orbiter measured Phobos' mass and volume with sufficient precision to calculate a bulk density of approximately 1.87 grams per cubic centimeter, far lower than solid rock, consistent with 25 to 35% internal void space. But the deeper problem with Phobos is its orbit. It circles Mars faster than Mars rotates, which means tidal friction continuously saps energy from its orbital path and drops it lower. Every 100 years, Phobos falls approximately 1.8 meters closer to Mars. At current rates, in roughly 50 million years, it will cross the Roche limit, the critical distance at which tidal forces exceed the forces holding it together, and disintegrate. Its debris will spread into a ring system around Mars. The red planet will have rings. We only have to wait approximately 50 million years to watch them form. Charon. Pluto was discovered in 1930 and treated for nearly 5 decades as a solitary object at the outer boundary of the solar system, small, cold, and alone in the dark. That assumption stood until 1978, when astronomer James Christie at the U.S. Naval Observatory noticed that Pluto appeared systematically elongated in photographic plates taken at different times, a recurring distortion that could only be explained by an orbiting companion gravitationally tugging on the primary body. The companion, named Charon, proved to be enormous relative to its parent, approximately 1,212 kilometers in diameter compared to Pluto's 2,377 kilometers, making it roughly half of Pluto's size. No other known moon in the solar system is proportionally this large relative to its parent body. Earth's moon is about 27% of Earth's diameter. Charon is 52% of Pluto's. This ratio fundamentally changes the classification. Pluto and Charon are not a planet and its moon in the conventional sense, but a true binary system, two bodies orbiting a shared gravitational center, the barycenter. that lies not inside Pluto but in the space between the two objects approximately 960 kilometers above Pluto's surface. Both are tidally locked to each other. Charon always presents the same hemisphere to Pluto, and Pluto always presents the same face to Charon. If you stood on Pluto's Charon-facing hemisphere, Charon would hang permanently fixed in the sky, never rising, never setting, occupying the same position through every season and every year. When NASA's New Horizons spacecraft flew through the Pluto system in July 2015, returning the first close-approach images of either body, it found something entirely unexpected at Charon's North Pole, a vast dark reddish region stretching across hundreds of kilometers, now designated Mordor Macula. The current scientific explanation is that methane escaping from Pluto's tenuous atmosphere drifts across the 19,600-kilometer gap to Charon becomes trapped at the cold polar region where temperatures drop near absolute zero, and is chemically processed by ultraviolet radiation into complex dark organic compounds called tholins. Pluto has been painting its moon's north pole dark red, one molecular layer at a time, across geological timescales through the vacuum between them. Amalthea. If you ranked every natural object in the solar system by the intensity of its surface redness, Amalthea would sit at the extreme end of the list. Redder than Mars, redder than any catalogued asteroid, redder than any moon for which a surface spectrum has been measured. It is Jupiter's innermost significant moon, orbiting at just 181,000 kilometers above the planet's cloud tops, completing one revolution every 9 hours. Its shape is irregular and heavily cratered, measuring approximately 250 by 146 by 146 by 128 kilometers, an elongated, battered body that looks nothing like the spherical moons of the outer solar system. The intense redness almost certainly originates from sulfur compounds. Io, the innermost of Jupiter's 4 large moons and the most volcanically active body in the solar system, continuously erupts sulfur-bearing material across the inner Jovian system. Amalthea's orbit places it in the path of this ejecta, where it accumulates sulfur deposits on its surface over geological time. But the surface color is not the anomaly that confuses researchers. The thermal output is, Amalthea radiates significantly more heat energy than it receives from solar illumination. At its orbital distance, regularly passing through Jupiter's shadow where solar heating falls to near zero, the moon should be measurably cold, with a thermal equilibrium temperature that the available solar flux can account for. Instead, its measured thermal emission consistently exceeds what solar heating can explain. The mechanism is electromagnetic induction heating. As Amalthea moves through Jupiter's extraordinarily powerful and rapidly rotating magnetic field, the changing magnetic flux through the moon's body induces electrical currents in the interior material, which generate heat through resistive dissipation, the same physical principle that heats a metal pot on an induction stovetop. The Galileo spacecraft measured Amalthea's bulk density during a close flyby in 2002 at approximately 0 timbol, 86 grams per cubic centimeter, less dense than liquid water. Its interior is either composed almost entirely of empty space or is an extremely porous rubble pile. Amalthea is the reddest object in the solar system, self-heated by a planetary magnetic field, and less dense than the water in a drinking glass. Ariel, of the 5 major moons of Uranus, Miranda, Ariel, Umbriel, Titania, and Oberon, Ariel has the youngest and most geologically complex surface of all of them. And in planetary science, young means active. Crater density surveys on Ariel's terrain indicate significant resurfacing activity within the past billion years, well after the point at which moons at Ariel's distance from Uranus should have exhausted their internal heat budgets and entered a permanent state of geological silence comparable to the heavily cratered surfaces of Umbriel or Oberon. The defining features of Ariel's surface are its chasmata, a network of deep valleys and structural troughs created by extensional tectonics, with a crust pulled apart along parallel fault systems and terrain dropped between them in a process called graben formation. Some of these valleys run for more than 1,000 kilometers in length and reach depths that rival the deepest canyons on Mars. Their floors are not bare rock but smooth, filled terrain, material that did not fall in from above but welled up from below. Planetary geologists classify this fill as cryovolcanic, water-ice mixtures, possibly including ammonia-water slurries that have lower melting points than pure ice, that intruded from the interior through the fault openings and pooled in the lowest terrain as the crust stretched apart. The combination of extensional faulting and cryovolcanic resurfacing requires a period of internal heat generation that was anomalously intense for Ariel's size and orbital position. Tidal heating from Uranus at Ariel's current orbital distance is insufficient by more than an order of magnitude to explain the observed activity level. The leading hypothesis invokes a former orbital resonance, a period in the past when Ariel's orbital period formed a ratio with one or more other Uranian moons that amplified tidal heating dramatically before the resonance broke apart and the system settled into its current configuration. Voyager 2 photographed Ariel during its single flyby of the Uranian system in January 1986. The cameras had hours, not days, over the entire system. Whether Ariel's cryovolcanism is genuinely extinct or merely in a quiet phase between active episodes is a question that no instrument currently in operation is positioned to answer. That's it for today. Subscribe for more, smash the like button, and drop a comment with your thoughts. I read every single one. Peace.